inverse. Okay. Should we do a quadratic? One more example of these. We have a few more things to do, but we'll do one more. Let's find the inverse. Domain and range for f of x equals x squared plus 3. Kind of looking like the one that I found before. Okay. Now, for a quadratic function, if I think about what this x squared plus 3 looks like, hope I know what those look like. Got a vertex at 0, 3. Parabola opens up. For a quadratic, there are no numbers that I can't square. So my domain gets to be all real numbers. But when I think about the range of this one, if I squish this parabola to the y-axis, I'm never going below y equals 3. So my range is going to be y is greater than or equal to 3. My inverse, it doesn't look like a parabola to you? Well, it isn't perfect. You're right. Gosh. Oh, what if it's x cubed? Oh, x cubes are easy. They're like linears. All real numbers for both. Yeah. So, and cubics too. So it's odd functions are easier than the even ones. Okay. So my inverse, I'll go x equals y squared plus 3. Solve for y, so that's x minus 3 equals y squared. A square root both sides of the equation, so I get plus and minus square root of x minus 3 equals y. My domain and my range. Well, my domain for the original function was all real numbers, so that becomes my range. And for my original function, the range was y is greater than or equal to 3, so for my inverse, that becomes my domain of x greater than or equal to 3. Not a function. My inverse is two functions, plus and minus square root of x minus 3. And when I go to graph it, I have to graph x plus 3. There we go. I have to graph both the upper part of this, the plus x minus 3, and the square root of x minus 3, and the minus x minus 3. Square root of x minus 3, sorry. And so that's not a function. The inverse is not a function? Yes, ma'am. If the original function is a quadratic, the inverse is not going to be a function. Okay? If the original function was a square root, then the inverse ends up being a function. But kind of like I showed on the board a little bit earlier, it ends up only being a half a function in this restricted domain. So if we go back and look at that second example, square root of x plus 1 look like that. Its inverse is y equals x squared minus 1. And if I'm thinking of graphing this inverse, I only graph half of a parabola, but I have already said down here that my domain is x is greater than or equal to 0, I'm only talking about that right half of a parabola when I'm talking about the y equals x squared minus 1. Because it was only half of a sideways parabola to begin with that square root function. Come on. Okay. So now let's go to some stuff that's not quite as hard, I think. Formulas. If I want to find the inverse of a formula, let's say I have a formula for science. This is distance equals r squared divided by 24. I don't know. This is something about a skidding car. I'm not even sure what r is when it comes to a skidding car. R miles per hour. Okay. So if I want to find the inverse of something that's a formula, I don't exchange the variables. I just solve for the variable that's not already solved for. So in this case, I'll just solve for r. So here we go. So to do my inverse, I got d equals r squared over 24. To get rid of that 24, I'm going to multiply both sides of this equation by 24, and I'll get 24d equals r squared. Square root both sides of this equation, and I'll get r equals the square root of 24d. And usually because it's a formula, the negative square root won't make any sense. Negative miles per hour is not going to make any sense, so I'm not going to bother with the plus and minus when I'm doing formulas. Sometimes they will make sense, but I think in this case it does not. And then there are composites of inverses. And this is kind of a fun fact. I-T. Okay, let's see if you can see what's going on here. I'm going to take a function f of x equals 2x plus 3. Can anybody do the inverse to this one in your head? Subtract 3, divide by 2. There's its inverse. If you couldn't do that one in your head, it's okay to work through the steps. Now I'm going to compose these two functions. So I'm going to compose my original function with the inverse, and I'm going to do this at 5. So just make it. I'm going to give you a number so you can see a little pattern here. So I've kind of went through a little bit earlier what you think that's going to be. First, I find f inverse at 5, which is 5 minus 3 over 2, which is 1. And then I take the leftmost function, the original function, I do that at 1, and I get 2 times 1 plus 3, and I get 5. Huh. I composed a function with its inverse. First I find the inverse function at that 5. I calculate it. And then, since it's a composition, I take the output of that one and I put it into the input I put it into the function on the left. I put that 1 into the function on the left. 2 times 1 plus 3, and I get 5. Okay. Let's do it again. This time I'll compose it the other way. We'll go for f inverse composed with the original function at 8. Well, first I do the function on the right.